Today I'm going to show you a demo of Jenkins as you've never seen it before. Every job pipeline, every piece of a pipeline that is scheduled and queued is going to run in a microVM that is created and then destroyed almost instantly. Let's go take a look at that. Here's a fairly modern version of Jenkins, and I'm working with pipeline builds. The main thing to keep in mind here is that we have a label. In this case, it's a label of Slicer, which means that we need to launch a microVM. We're going to get the host name and sleep for a number of seconds. In the background, I have Jenkins master. This happens to be running in a Slicer microVM. It doesn't need to run there, it could run anywhere. And then I have Slicer running on this slaves. So if we were to have a look at that file, we basically see that we're using ZFS storage for an instant boot from a snapshot, 2 vCPUs, 8 gigs of RAM. That's what we're going to have, pretty standard configuration, but this could be changed via API dynamically. And then we have a custom image. The custom image is just basically accelerating what you would get anyway from the Slicer base image. So it's pre-installing Java for Jenkins. It's installing Docker and adding Jenkins into the user. Now, you don't need any of that necessarily, but I've added it just to speed up a couple of the demos I'm going to show you. And then we start Slicer. It's got 0 nodes in it right now because the API will add them. Then we click build. That icon right there was it booting, and it's already connected and running. And it's doing the sleep stage now. Here we see the VM launched, and it's finished. Now we can also run the fstail command. It's a bit more advanced than tail because it can attach to new files as they're created. We'll go and let's run 2 at the same time. We do build 2 and 3. You see they've been added in Jenkins. The microVMs in the background are booted, and this is the output from Jenkins agent. I can also use the list command from Slicer on that host group, and I can see the 2 VMs there. Now I could just see the last one, and the last one is finishing off, and now they're all gone. Quick as you like. So now let's look at something a bit more advanced. We'll go into Docker, and this is one of the real reasons you might want to use a microVM. We are able to run an entire Docker instance that's completely isolated from the host and any other workloads or systems. We don't need Docker in Docker. We don't need to mount a Docker socket and be concerned about the versions. We can run a full-blown Kubernetes. That's actually the next demo. So we're in. We've run a Docker container that did a ping to Google for 4 pings. The image was pulled. It's done, dusted, removed again. Now let's look at K3s. In this example, we're running a Kubernetes cluster, something that you really can't or shouldn't be doing with a mounted Docker socket. First thing we do is we just download a couple of tools, K3s, kubectl. We then install it, wait for it to be ready, and get the nodes. So this would be great for an end-to-end test. I've hit build. I just saw the launch there, and we're already literally connected and running that quickly. K3s itself can take a few seconds to start up. That's just because it does a lot of things, pulls a lot of images down. And then once it is running, you can run your kubectl commands. Go do your end-to-end tests. Do it at the end of a build for an image that you've just pushed. And that's it, finished. In the background, you see some debug logs and information. This will be a little bit less verbose out of the controller and our cloud plugin. How the cloud plugin works is through uploading a plugin and then adding a cloud. In this case, there is a URL for that cloud. It has a token and it has a host group. And so you could have multiple behind this, or you could have one. We've just got the one right now. In the last demo, I'm going to run all of them. I've got a little variable tuned where I think our cloud is set to only run so many. But as you can see, they're all launched there. Let's double check what it's set to. So we're on 4. So if we put that to 5, they should all run at once. So for now, the first 4 will run, and then we can see Jenkins just picked up that last one. That's running on the stack. But now that we've edited it that to 5, we've got to even put it at 10 or 20, that's how many jobs we can run in that cloud at that one point in time. So this is pivotal for Jenkins. I don't think anybody else has done this yet, or may not even have the appetite to go and do this. It is not trivial to build a Java cloud plugin and to understand the full workflow and lifecycle of microVMs. We're doing that. We've used Slicer here, but it's based on the core technology from actuator.com, which you may know a bit better for GitHub and GitLab. If you'd like to modernize your Jenkins setup, if you'd like to make it faster and more secure, please reach out to me, alex@openfast.com. I'd be very interested to hear from you. Okay, thanks.